Hello everyone, myself Purushotham, working as Assistant Professor in Department of Computer Science and Engineering, MLR IT. In this session, I am going to explain about thread life cycle states. So, this is the overview of this session. So, first I am going to explain thread life cycle states, then after I am going to explain thread priorities. Okay. So, first I will explain what the thread life cycle states. So, coming to the thread life cycle states. So, in a thread we have what total 5 states are there. Okay. So, first one is a new state, next runnable state, next running state, next non-runnable or blocked state, and last a terminated state. Means a thread can be any one of this state. Okay. So, here suppose if you take a diagram here, you can see if you are creating a thread can be in any one of the state. Okay, sometimes a thread may be in new state, sometimes a thread may be in runnable state, sometimes thread may be in running state, sometimes a thread may be dead state, or sometimes a thread may be in blocked or waiting or sleep state. Okay, so when a thread will be enter into the new state and runnable, running and dead and blocked state, now we'll see now. Okay, now so suppose whenever you are creating a thread. Okay, so whenever you are creating object to the thread, so your thread will be enter into the new state. So suppose assume I have a my own thread. So suppose let's take an example. I am creating object to the my thread class. My thread t equals to new my thread. So here I created object to my thread. Now whenever you are creating object to the thread will be enter into the new state. But actually, so as per the Sun microsystem, so there is no new state. Okay, there are only the 4 states, but for our convenience, we can make it as like the 5 states. So whenever you are creating object to the thread class, so automatically your thread will be enter into the new state. And when a thread will be enter into the runnable state. Okay, so here after creating object, so to start your thread, so compulsory what we need to do means we need to create object. So here I created object and I am calling what a start method. So if you call the start method, now what will happen means your newly created thread will be enter into the runnable state. The runnable means it's not interface, it is ready to execute. It is what? Ready state. Okay, in other terminology we can call it as a ready state. Okay, so ready to execute means all the threads, eligible threads are enter into what? Runnable state. So suppose assume here I have the T thread, the T thread is ready to execute. So that will be enter into what? The running state. Now the from runnable state to the running state. So when a thread will be enter into the runnable state to the running state means if a thread scheduler is decided to what? The particular thread has to be executed. So suppose assume here I have what? The T1 thread, T2 thread, T3 thread and T4 thread, assume. Now from this thread pool, so suppose thread scheduler is what? Selecting what? The first thread. Now the first thread may got a chance to execute on the what? CPU. So if the thread scheduler is decided to execute and that particular thread will be enter into what? The running state. So that is what? It will execute on the CPU. And if the thread job is done, okay, thread will be enter into the dead state. If the execution is done means, so the thread job is done, so automatically thread will be enter into the dead state. Now if you observe this diagram, the new thread and the dead thread will be execute only once in thread life cycle. Okay, so suppose if thread is enter into what? The new state and from new state to runnable state, so there is no chance to go back to what? The runnable state to again new state. Okay, means new state and dead state just like a birth and death. Okay, so it will happen only once in a life. So same the way in thread life cycle states also the new state and the dead state is execute only once in the thread life cycle states. So the remaining 3 states will be what happens multiple times. Okay, now here the running thread, sometimes you may call what the different kinds of methods. Sometimes you may call the wait method, sometimes you may call the sleep method, sometimes you may call the suspend method. If you call any of these methods, now what will happen means the running thread will be what stops the execution and it will enter into the what the blocked state or waiting state or sleeping state. Okay. So, suppose if you are called the sleep method, it will enter into the sleep state. So, suppose if you are calling the wait method, it will enter into the waiting state, and suppose if you call the suspend method, it will enter into what the blocked state. Means the temporarily the execution of the thread will be stopped and it will enter into what the blocked state or waiting state or sleeping state. Now, so from this sleeping or blocked or waiting state, again the thread will be enter into what runnable state only. Okay, now so from blocked state to waiting state and sleeping state, so thread never enter into what the running state directly. So if it is a blocked or if it is a waiting or if it is a sleep state, so the thread will be enter into what the runnable state only. Okay, now so when it will be enter into the runnable state, so suppose here you are calling the wait method, and if the waiting is done, so if you are calling the notify and the notify all, the thread will be enter into the what blocked state to what waiting state to the runnable state. Or here you mentioned the sleep method. So suppose assume the sleeping time is like suppose 10 seconds. Okay, so after 10 seconds the thread will be enter into what the sleeping state to the runnable state. And if you are using what the suspend state, means it will enter into the blocked state now. So if you are using the resume method, so automatically the thread will be entered into blocked state to the runnable state, and from runnable state to again it will enter into the running state. So if you observe here, one more method is there, that is a yield method. Now when a thread will be what enter into what the runnable, running to the runnable means if you apply the yield method. So suppose if a thread is executing the long period of time, so suppose let us take an example. So T1 is executing currently and the T1 is taking what the 5 hours of time, assume. Now the T1 is executing. Now suppose if any other threads are there in the waiting state, so let us take an example, T2 is waiting for what a CPU, but T1 is executing here and the T2 is waiting. So if you are using what the yield method here, so the T1 temporarily stops the execution and directly it will enter into the runnable state, and T2 may got a chance to execute on the CPU. Okay, so when it will be execute means if you apply the yield method, it will be execute. Right. So these are the life cycle states. So as per the Sun Microsystem, actually we have only the 4 states only, but as per our convenience we can categorize it into 5 types here. Okay, so new state, runnable, running, dead and blocked, waiting or sleep state. Okay, so here in this diagram, so compulsory we should remember these methods, wait method, sleep method and suspend method here. Okay, and here the yield method we need to remember. And so from blocked to waiting, sleeping to what the runnable or waiting to runnable, blocked to runnable, so we should use what notify method or notify all or resume method or when the sleep time is up. So these points compulsory we should remember in this diagram. On the same points I just discussed. Now, so coming to the thread priorities. So every thread in Java has some priority. Every thread in Java has some priority. Okay. Now, so it may be the default priority provided by the JVM or customized priority provided by the programmer. So default priority provided by the JVM means the default provided by priority means the 5. Okay, so it is provided by the JVM, or if you are not satisfied with the what priority, you can also customize your own priority. Okay, you customizing means the priorities are actually ranging from the 1 to 10. So 1 to 10 any number you can assign. Okay, so depends on your requirement. So the valid range of the thread priorities are 1 to 10. Okay, so the priorities are ranging from 1 to 10. So 1 means min priority and 10 means max priority. In between 1 to 10 you may have what the 5, so 5 is a normal priority. normal priority. So the priorities are ranging from 1 to 10 only. So compulsory we should pass the values 1 to 10 only. If you are passing any other than what the 1 to 10, so it leads what exception. Okay. So compulsory we should pass 1 to 10 only. So 1 means the minimum priority and 10 means the maximum priority. In between 5 means normal priority. So the default priority of the main thread is a 5. So as I mentioned, the default priority provided by the JVM. So JVM is allocating for every thread. So the default priority as a 10. So as we know that in any Java program, you have what main thread and you have the monitor thread. So what is the priority of the main thread means that the priority of the main thread is a 5 only. And if you want to, you can customize the priority and depends on the requirement, you can increase the priority or you can decrease the priority. And these priorities are inherited from the parent class. If you are creating any child class to the parent class and whatever the priorities of there for the parent class, the same priority can be inherited to the child class. Okay. So thread scheduler will use a priority while allocating the processor. The thread which has highest priority will get a chance first, and the thread which is having the low priority will get chance what after execution of the thread, sorry, highest priority thread. Okay. Now if you observe here, so the thread may get a chance. Okay. So there is no guarantee here. So if suppose even if you are applying the high priority, so there is no guarantee. So JVM may ignore what these are priorities here. Okay. So suppose if you take an example like CPU, I have the multiple threads like T1 thread, T2 thread, T3 thread and T4 thread. Now assume that T1 is having like priority is 10 and T2 is having the priority is 5, the T3 is having the priority is 4 and T4 having the priority is 1. Now if you observe these 4 threads the priority, the T1 is having the highest priority. Okay. So among these 4 threads, so the CPU may consider the T1 first. Why means it is having what the priority is 10. And so which thread will be what get what least priority means here after execution of all the threads, T4 may got chance. Okay. Why means it is having the least priority. But still this priority may consider and sometimes this priorities may not consider. Okay. So again your output will be varies and your output will be depends on your vendor. Okay. So if your operating system is not considers these priorities, so these priorities may be ignored. Okay. Now, so if the 2 threads are having the same priority, then we cannot expect exact execution order and depends on the thread scheduler. Okay. So suppose the CPU again having what the multiple priorities like T1 and T2 and T3 and T4. Now the T1 is having the priority is 7 and T4 also having the priority 7, T2 also priority 7 and T3 also priority 7. Now if you observe all these threads, the priority is what common means 7 only. Means all threads are having the equal priority. Now the which thread will get a chance to execute first means we cannot predict. Why means here every thread is having the equal priority and in such cases we cannot predict exact output and the output will be decided by the what the thread scheduler based on the thread scheduling algorithm. Okay, so the thread scheduler may consider what algorithm like FIFO, first come first out, or it may consider shortest job first, or it may consider what the round robin, or it may consider what the priority scheduling, or it may consider what any other algorithm. Okay, so the output will be depends on the thread scheduling algorithm. So output will be decided by the thread scheduler program. So the thread which is having the low priority has to wait until the completion of the high priority thread. So suppose if you have the multiple threads and the thread which is having the low priority, the thread which is having the priority is 1. Okay. So the low priority thread must be wait until the completion of the high priority threads. Okay. So here three constant values are there in the thread priority. So one is a min priority, second one is a norm priority, and third one is a max priority. So these are the constant variables. So these are the constant variables: min priority, norm priority, and max priority. So these are the public static and final variables. So these are the public static final variables. So that's why every character here must be uppercase. Make sure, so compulsory we should write every character must be in uppercase. So these are the predefined, these are the predefined constant variables in the thread priorities. Okay. So min priority, min underscore priority means it will be 1, and norm underscore priority means it will be 5, and max underscore priority means it will be 10. So thread class defines the following methods to get and set priority of the thread. So as we know that we can also customize the thread priorities. So how to customize the thread priority means we need to use what the special methods and the predefined methods available in the thread class. So that is what the set priority and get priority. Okay. So here get priority means if you want to know any particular thread priority, you need to use what the get priority method. And if you want to know if you want to set a priority to any thread, we need to use what set priority method. And get priority method will be return integer. Why means the priorities are ranging from 1 to 10. The priorities are ranging from 1 to 10. 1 to 10 are integer values. So that's why the get priority is what? Returning integer value. And set priority method is accepting integer, okay, as a priority. You can see here it is accepting integer value. So the priorities, again the priorities you need to pass here, the priorities are ranging from 1 to 10. So 1 to 10 are the integer. So compulsory we need to pass integer only here. If you are passing any other than what integer, it leads what the compile time error. Okay, exception it will throw. Next, so here the priority indicates a number which is the allowed range 1 to 10. Okay, as I mentioned, here the priority is there now. So this priority means the number we need to pass 1 to 10 only. Okay, so suppose if I pass 0, okay, it will throw the exception. Suppose if you are passing 11, it will throw the exception. Even 0 and 11 is an integer only, but the valid range of the priorities are 1 to 10. If you are passing what any other than these range, so it will lead what the exception. So the exception name is a illegal argument exception. Illegal argument exception. If you are passing any other than what 1 to 10, it leads what exception. The exception name is a illegal argument exception. So suppose if I take an example, so I want to prove this point. So let's take an example. I will take a class. The class here I will take my thread. System.out.println and I equals to 0, I is less than 10, I plus plus. So here I want to print the current thread priority here. So to print the current thread priority, so here so thread priority I want to print here. So current thread dot, so currently executing thread priority only I want. So here I want to use a current thread method, current thread dot get priority. Okay. Now here I will create an object to the my thread. So here I am creating object to the my thread. So T1 new my thread. So T1 dot start method. T1 dot the start method. So as we know that here we did not mention any priority to my thread. Okay, we are not mentioning any priority to my thread. So means it will take the default priority. The default priority of the thread is a 5. You can see here the thread priority, it will print thread priority 5 like that, it will print 5 times. You can see thread priority 5, thread priority 5 like that, it will print the 10 times. Now suppose if you want, you can customize the priority like T1 dot set priority. set priority method, and the priorities are ranging from 1 to 10. So suppose let's take an example, I mentioned 1. Now the priority of this thread will be changed here, and it will print, now this time it will print 1. So thread priority 1, thread priority 1, like that it will print the 10 times. Now suppose if you want to increase the thread priority to the 10, and it will print thread priority 10, thread priority. So any number you can give. So 1 to 10, any number you can give, like suppose if you give 6, the 6 it will print thread priority 6, thread priority 6, like that it will print. Now you can see. And so apart from these numbers, you can also pass some constant values. The constant values, as I mentioned, like min priority, min underscore priority, max underscore priority. So here I will pass the min underscore priority. So here the min underscore priority is a thread class variable, the predefined thread class variable. So just use what? Thread class, thread dot min underscore priority. If you pass the min underscore priority, as we know that the min underscore priority internally it will take it as a 1. Okay, so it will print 1 now. Same the way, if you want, you can use the variables, the predefined variables, thread dot max priority. Okay, so thread dot max priority I am calling. So it will print, now this time is a 10. Now if you call the norm priority, it will print what? The 5 only. So you can see norm underscore priority. You can use this. Okay, it will print 5. And if you are passing any other than these values, like suppose if you take an example like 0 I am passing. Now the 0 actually it is integer value only, or else if you are passing the 11 also it is an integer. But actually the thread priorities are ranging from the 1 to 10. But if you are passing what? The other than 1 to 10, so it leads what? Exception and illegal argument exception. You can see here it will throw the exception, illegal argument exception. So here the make sure the compulsory, while working with the thread priorities, compulsory your thread priorities are ranging from 1 to 10 only. So compulsory we need to pass 1 to 10 only. So if you are passing any other than, it leads what? Exception. So to set the priority and to know the priority of the thread, we need to use a special method. To set the priority, we need to use a set priority method, and to know the priority of the particular thread, we need to use a get priority method. Okay, so coming to the summary of this session. So in this session I have explained the thread life cycle states and a thread priorities I have explained. Okay, so that's about this session. Thank you.